Okay, I know I keep dangling the homework assignment out in front of you, but first we need to squeeze in one more topic. We're going to talk about enumerations. I want you to think back to the homework assignment on day one. I asked you for double extra bonus points to change the text color of the window. And so to solve that request, see in line 59, we did something like this. Console.foreground color equals console color dot red. And I asked the question, well, why do you think we have to use, console color dot red? And I said you can't just use the word red because it has no inherent meaning. But what I glossed over was the console color dot red phrase. And I think that I even said that, console color was a class and red was a property of that class that defined the color red. I did that because I really didn't want to introduce the topics of enumeration that soon in the process. An enumeration is a special kind of type that only has certain values defined as possible values. So since the foreground color of the console window is of type console color, I could not possibly set it to any other value. This was a smart move on the part of the developer who created this enumeration or this class or foreground color to restrict the possible values and reduce the possibility that a user could set it to an illegal value, such as a literal string or a hexadecimal value and so on. Now, if I were to try to duplicate that developer's work, I might do something like this. Now, let's see. Let's create a new area here. I might do this. Enum console colors. We'll give it a different name just to avoid any potential problems here. But I could do red equals 1, and then blue equals 2, and black equals 3, and so on. And I could create more if I wanted to. And then what I would do is I could use that within my application. So console colors dot, and those are the only three possible values that it can be set to. All right. So what I would do then in my console class, if I were to have a console class, is that I would translate either red, blue, or black, those little phrases there, into a proper value that the computer can understand to represent that associated color. So I want to revisit another example. Let's do this. Let's delete that, get that out of there. And instead we're going to go to our make property on our auto class. Here, let's just find it like we learned here, or maker. Here we saw quite a difficult little, or quite a verbose way of checking to make sure that the literal string that the user is trying to set maker to is only one of several possible options. It can either be Oldsmobile or Toyota in this particular case. But I could eliminate a lot of code here, assuming that I can make this a small set of values, 2, 3, 5, 10 potential values, by creating a make enumeration and then defining our maker property as of type make enumeration. So I might do this. Let's go in the same class here. Go down to the bottom, past the class and before the end of the namespace. And I'm going to go enum make. And we're going to go Oldsmobile and Toyota. And let's go Chevrolet and Ford and I don't know, GMC. Okay, and then up here, what I would do when I define my maker property, let's first start out with make, because we're going to need to change make from string to make. See that? It knows that I'm talking about the enumeration make. Then here, what I would do, public string maker, I would change this to make. And now I could all but eliminate all this and instead just say make equals value. And I can eliminate all of this. Why? Because now if we go to the program.cs and I'm going to try in my truck maker equals, and you can see it pops up by default that make enumeration, and I only get several potential values from it. Okay, so what did I just do here? Well, the benefit of this approach is that it is strongly typed. Strongly typed. That is a phrase that you're going to hear a lot with reference to C# and the .NET Framework. Strongly typed as opposed to our previous message, which is called weakly typed. Weakly typed means that invalid values can't be checked at compile time due to the use of magic strings, another phrase you might hear often, more of a nickname. A string can be set to any value. And so at runtime, if the value is set to something illogical and our application depends on that value for some business rule, calculation, or decision branching, then we've introduced a possible issue within our code. So in the code that we wrote, we had to go through in auto.cs to avoid that situation. We had to write a bunch of checks, a ton of code, to make sure that it could only be one of several possible values. Now, if we were to forget those checks that I've just highlighted there, then we would definitely have an issue. The consumer of our class could set it to anything, even something nonsensical, that would make absolutely no sense in the context of an automobile application. Set it to Lollipop, instead of BMW. Okay. So if I define an enumeration like I did here at the very bottom of the auto.cs class, I can eliminate all those checks that I did earlier. At compile time, if the value is not set correctly to one of those enumeration values, then the compiler is going to complain and it won't allow the application to be compiled. Let's just demo that really quick. I'm going to set maker equal to the literal string for it, or better yet, let's set it to BMW, which we did not define. Now, first of all, I get this, I get a red squiggly line within the text editor that says you can't implicitly convert string to the enumeration of make. If I try to compile it, I'm going to get an error. Okay, an exception. So we have to use make dot one of the make values. That makes it strongly typed and it cannot be broken at runtime. The breaking happens at compile time. All right. So this is a good thing because we can check up front to make sure that the types are correct, and if they are, then we can have confidence in our code that it's going to work once we deploy it and let other users actually use it. They're not going to be able to break our code that way. Maybe another way, but not that way, okay? So in this video, we talked about defining enumerations in C#. We talked about how enumerations help us to write strongly typed code that will be less likely to break at runtime. We talked about weakly typed code that depends on magic strings that can't be checked at compile time and may require some extensive checking in order to ensure that they work correctly throughout the application, like the example that we had earlier with our maker property where we did all that, the switch statement, and threw an exception if there was a problem, right? We had a few magic strings involved, Oldsmobile, Toyota. We were able to eliminate all of those as a result of this. So enumerations are one way to maintain strongly typed code and to gain confidence in our code. And we're going to see some other ways to do exactly that throughout our time together. And I'm going to make sure to point those out as we go along. Okay, so that's it for the code portion of our lesson today. Now I think we're ready to get into the homework assignment. Please do it. We'll see you in the next video. Thank you.